This next part of the notes, I'm going to look at part of 4.2 and 4.3 all at the same time and kind of group two ideas together because it'll make our lives a little bit easier. Is I actually want to talk about what are called conditional probabilities first, and then we'll talk about something called the multiplication rule. Conditional probabilities are probabilities that change based on the given set of conditions. That's why it's called a conditional probability. It's changing based on the conditions. So here's a perfect example. We've got a bag that has 3 red marbles and 4 green marbles. And you're going to draw 2 marbles from the bag without replacement. Question is, what does without replacement mean? It means once you draw 1 marble, you don't put it back. It is out of the bag, and your bag's, the conditions for the bag have changed now. You've got 1 less marble in your bag. So your probability for drawing that second marble has now changed because at the very least you've removed a marble from the bag. So let's look at the events that they want us to look at for this example. Is event A means that you drew a red marble first, and event B is that now you want to draw a green marble in the second draw. So here's what we're going to look at is, given that A has already occurred, what is the probability of B happening after that? So here's the idea. We're going to start out with event A, drawing a red marble in the first draw. So the assumption is that has already happened. So the idea was we started out, here's our bag. It had 3 red marbles. And 3 red marbles and, 4 green marbles. And then the idea is they're telling me, assume that you already did event A, that you drew a red marble. So it's gone. It's out of the bag. Now the question is, what's the probability of now, with what's left, now that the conditions have changed, what's your probability of now drawing a green one? Well, now I didn't touch the number of green marbles. I've still got 4. However, I did originally have 7 marbles, but I took 1 out. So now I've got 1, 2, 3, 4, 5, 6 left because I removed one of the red ones. It was not replaced. So I have 4 green marbles out of a total of 6 that were left. 4 of them are green, and only 2 of them are red because one of the reds already got removed. So my probability of drawing a green marble after I already drew a red marble is now 4 out of 6, which is 0.667. And the notation that we would see for this conditional probability is this little slash thing. So it looks something like this. Find the probability of drawing a green, and then you'd see this little line, which says, assuming that you already drew a red. So whatever you see second over here has already happened. Assume that that's already happened. Now find whatever you see first as happening after you already did your first thing first. So we drew a red. So we were up at 3 red marbles. Now we're down to 2. How many greens are still left? 4. But now how many marbles are left? Only 6. That's what we found out, which gave us a total of a probability of 0.667. So when we have conditional probabilities, we're going to see this slash when we're talking about conditional probabilities, or we'll see this weird wording of given that, or you'll see another wording that you'll see a lot is assuming that. And that's how you're changing your conditions. So that changes your probabilities because you're either changing the group that you're looking at or changing what has already happened. Here's another example. 2 cars are selected from a warehouse of 50 cars. 5 of the cars in the warehouse are defective. What is the probability that the second car is defective given that the first car was defective. So the way that I think of it is, here's my little warehouse. I've got 50 cars in here total. And here's my 5 clunkers, my defective ones. Okay. So what they're asking me to find is find the probability that the second car is defective given that the first car was already defective. So the thought is you have to assume that the first car was already defective that they selected. So this defective car was selected and it was taken out of the warehouse. That has already happened, so let's check that off. But you did take a car out of the warehouse. There aren't 50 anymore. There are now 49. So what are your chances of this next one also being defective? Well, let's look. How many defective cars are left in my warehouse? Well, now there's only 4 defective cars left, and there's only a total of 49 cars left in your whole warehouse. So my probability of the second car being defective is 4 out of 49, which is 0.082. That's your probability of the second car now being defective, assuming that the first one was defective. And again, remembering, I'm going to keep on using the slash so they'll get used to the notation, because that's a notation you'll see when we're talking about conditional probabilities, or you'll see the wording that we saw here, which is given that. Again, find the probability of second car being defective given that the first car was defective. That's how you know you're looking at a conditional probability, where we were able to just say, oh, well, now that the first one was defective, there are still 4 defective cars in your warehouse out of your total of 49, which helped us find the probability. Let's try another one. 2 dice are rolled. Find the probability that the second die is a 4 given that the first die is a 4. So it would look something like this. Find the probability of rolling a 4 given that you already rolled a 4. Well, so the problem with a die is, okay, I rolled a 4 on the first die. That doesn't actually change anything for the second die, or even if we had used the same die all over again. The reason why is your die doesn't change. There's still only 1 4 on your die, and there's still 6 options on your die. That doesn't change. So you'd still do 1 out of 6, which is a probability of 0.167. And the reason why nothing changes with a die is because you don't pull something off of the side of a die. It stays the same. You can't change the conditions of a die. So what we say about die, the die example of rolling dice, is actually that they're special. That what happens on one event doesn't affect the other, which means that they're called, this first vocabulary word, independent. Because whatever happens first or on one die is not going to affect it on the second die, or even if you use the same die over again, because the die can't change. You can't remove something. You can't change the conditions. And that's what these fancy formulas say, basically, is if you have 2 events that are independent, they're not going to affect one another. Meaning the probabilities will stay the same. They will stay equal. What happened on the first thing, on the first die, won't affect the second die. However, something like a deck of cards is not the same, possibly, depending on how you approach the problem.